lies with KL main campus. Actually, our associate dean. So since if you look at your program structure, you will see that your next semester you have project one, right? So that means this semester is the time for you to do your project proposal. All right. Okay. So I'm contacting the person in charge for FYP. FYP in KL. Right. So after that, after I get all the necessary info, I think this week we're going to, including Farah. Farah won't be joining us this afternoon. He told me already. But we'll continue anyway with our lecture. But the three of you, RSD2G1, okay, means there are two things. One is that you guys will, one, be allocated with a supervisor. This supervisor will be guiding you or supervising your final year project. We call it FYP, throughout the proposal, project one, which is uh, next semester, right? And then the semester after that, project two, right? So until completion. So the FYP runs across, if you count the proposal, which is this semester, across 3 semesters. But the two that project one and two is the two actual courses within each semester, right? So the marks from the proposal is actually one part of project one. Okay, project one, there's a whole host of rubrics to mark your whatever you're doing inside the project one. And the first one is the proposal. Okay, later on, I think during this week, when we call for the meet, I will create a Google Classroom for that to share with you all the forms and documentation for the project proposal. Project proposal basically just you come up with a short brief about your proposed project that you want to do, right? So in the main campus, usually what will happen is that the students will try to get one of the lecturer in the list as their project supervisor. Okay, but for most of them, basically, if they can't find or they don't really want to find, and they will be allocated to the project supervisor, right? So at the end of the FYP, okay, if your project is can be selected and you can submit it for symposium, right? Symposium, usually, typically, we allow the students to display, because this is the capstone for your degree, to display their project, okay, to the industry. We call in industry people to look at your, your project, all this, right? So that's good exposure, right? By this time next year, I think we are in endemic phase already. So I really hope. In any case, FOCS is planning to basically start face to face next semester, right? Barring anything bad from happening. So I'm pretty sure by the time you finish your final year project, it's already face to face. So we might be able to do the symposium here in Sabah as well, right? So of course, selected one lah. If you got very good grades for your project, it means your project is really good. Then it will be can join lah. Then you will create poster, things like that. Also, uh, I think you can do project solo, right? Or you can do in a group. Okay, in a group means only 2% per group. Okay, but for 2% in a group, it is very clear who is doing what. It means, let's say, it's the one way to do it is that, let's say you come up with a project proposal. So if it's large enough that you can divide the work into 2%, then it might be accepted lah. Or you can do the same project, but maybe one of you are doing web-based application, or the other one might be doing a mobile app application of the same application. Or you can functionally divide it. Maybe if it's a large enough project, one person might do the the back end administration part, okay, and then the other one maybe do the client part or something like that. Yeah, it depends lah what the project is. Or you can do solo, right? Solo, of course, solo, the scope will be good enough for one person, and then the for two-person doing maybe slightly larger the scope lah, so that it's enough work for both students, right? So I hope this week we can arrange the Google Meet to elaborate more on this. All right. So at the end of the semester, just the deliverable will be the proposal, the form, the proposal, short brief basically. But you already identify lah. You did your initial study, the literature study, so that you can come up with your proposed functionality in your project, and that's it. Okay. All right. Okay. So we'll discuss more about that later. Okay. So I think two of you already here. Hello, Kelvin. And Noel is also here. Farah, I think he's already told me that he got something to do today, right? So we'll proceed, yeah. Okay, so right, so I'll start with the course introduction, right? So I'm going to share my screen over there. Hang on, that. All right. So how was your experience joining the class in KL? So,
it's pretty
your
first impression. There's a lot of people.
You can talk to me by using the microphone. Oh, hang on. Shaq is talking in here. Right. Okay.
Oh, there's
All right,
more people than I expected in the.
Yeah. Yeah, you're only in one group, right? In fact,
yeah.
When you combine all the groups together, you can see that it's more than 100, I think, because networking goes beyond RSD, go to RSF. That means software engineering also taking it, and I think this is one of the core subject in any of the MQA program. They have this guideline, so it's really large sometimes, and so that's why you join the smaller group for tutorial and practical. Okay, now I was initially at the beginning of this during the semester break, I already started to check out our Cisco lab, right? But then when I note that when I contacted all the other branches and main campus, FOCS still want to do online this semester. They don't want to rush out and face to face, just in case they're really concerned about both lecturers and students' health, right? So, but they do decide to go face to face next semester. Now that means we are going to do online, means we're going to use a packet tracer, right? But I will arrange with our. You guys are staying near KK, Bagan? Kelvin and Noel?
Oh, yeah.
In the Beverly Hills, Pinampang there.
Noel, where are you staying?
Near the campus.
Near the campus. Oh, okay, good. Oh, before I start, continue. Are you guys? Is it clear? Can you hear me?
Yeah.
Clear? Can
Yeah, clear.
Okay. Now, we might try maybe once or twice. I just let you guys or maybe we go to campus and see any slot. We just go to check out our, what to say this, Cisco hardware lab. Maybe we will try, but we follow SOP lah. We'll inform the workers when we want to come in, right? So all our assessment basically using packet tracer, but maybe just to let you have a look, see our equipment, try out something like that. The thing is, at the moment, our equipment is waiting for a rack. So don't worry, next semester is ACN, right? I hope by next semester we'll have it up and running, right? So because face-to-face already, so we should be able to use it, okay, for ACN. So after this, the computer networks, you have advanced computer networks, okay? Right, so let me just go through with this introduction first very quickly, yeah? Right, so as usual, we're going to use NetAcad. I'll try to get the tokens and register you guys, or you guys register before our practical, which is towards the end of this week, right? And so I hope you still remember your password to enter you're going to use it all the way to ACN, Advanced Computer Network, right? Okay, so just to let you know where you are right now, if you look at the screen, the slides, we are now here doing CN, right? Computer networks, okay? Which is previously we have FCN. Remember FCN? We did that earlier on, okay? Halfway with you guys, and then halfway with KL. After CN is ACN, Advanced Computer Network, right? So you note that all the CN color here highlighted are the new or significantly changed content from Cisco. It means that there's a difference with the previous version. Okay, Cisco always updating their contents so that is still relevant with the industry. So they see that the land security concepts is important, so they actually, and then they will take out those not so everything is relevant, but less relevant from their syllabus. So switch security configuration, one of them, right? And wireless LAN, okay? Because nowadays, of course, wireless LAN is everywhere, okay? Wireless LAN is something that if you can do it or provide it, wireless LAN is popular. So that means wireless LAN concepts and configuration is added for CN. So we'll see that inside here. And then for ACN, the Advanced Computer Network, the course after this, again, network security, very important nowadays. Although we don't hear so much, we read about it, but it's actually happening, okay? But a lot of companies, this is bad publicity, right? So it goes unreported, okay? Because it devalues their customer or reduce the customer's confidence in their company if they report, okay? If they report, oh, we have been security breach, okay? But it is something that is very important and is growing because more and more attacks. So network security concepts added there, and you can see there VPN, virtual private network, and IPsec, IP security concepts. And the other one becomes very important now, especially with 5G coming in, right? 5G, I don't know whether you guys recall last year, if you joined the talk, I invited the Cisco guy, right? Cisco engineer to give a talk last time on 5G. He was talking about software-defined network. Those are considered as network automation, okay? Simply means that traditionally all network engineers, what they do is they configure manually. They go into those hardware switches, routers, configure very task intensive, right? Manually configuration. But with SDN, software-defined network. It's all taken over by software. Okay, and that's the future. That's the way networking is going to be. So that's why we talk a little bit about network automation over here. All right. So, and you can see that these are part of the CCNA version 7. Series 7 version 7 is actually highly regarded in the industry, as I mentioned in FCM last time, right? And there are 4 modules, but we give you guys about the three courses in your program that actually covers the 4 modules. So once you finish your degree, if you want to go and you want to go and sit for CCNA, you can, right? It qualifies you as a network engineer if you have CCNA. Just in case you want to explore networking as a career, right? But it doesn't hurt if you got that, even if you're a software developer, right? Mm, all these other courses, right? You can explore them on your own. But once you are in NetAcad, sometimes you see some of the courses here. You can explore them as well, right? It's up to you. Okay. All right. So here is where we place it just now. The previous, this is diploma, but very similar to the introduction to network. You guys took fundamental of computer networks, right? But different course code lah. But this one is diploma course code, right? For diploma level, they only take FCN, single. And for first year, I think your degree, they take this one also fundamental computer, is which map to CCNA, introduction to networks module, right? So now you're doing computer networks, okay, BMIT 2164, which maps to CCNA, switching, routing, and wireless essentials. Okay, so the next one that you're going to take after you pass this course will be advanced computer networks, which map to enterprise networking, security, and automation. Okay. Right. So I left this in your Google Drive, the classroom Google Drive, or you can have a look on your own. Right. So this is CNA Introduction to Network. And then after that, this is the computer networks, right? You can read all about this on your own, but it's basically mapped already with our syllabus, yeah. You can see here. So example there, and then this one's advanced computer network, right? So you can see so every module builds up on the previous modules knowledge. So when you think about it, you learn about packet tracer, and you go to computer networks, you're still gonna be using those skill sets in computer networks and bring it to SCN as well. But of course, you learn more iOS commands. Okay. Right. Okay, submission of weekly tutorial answer, lab practical. So tutorial answer, yes, you guys, would you guys prefer to do a tutorial answer on your own, or you want to share like exactly like what we did last time? I kind of prefer the way we do it last time because I can give you straight feedback and you guys can see, can attempt some of the questions, and then each of you got allocated questions and you can answer them straight away. I check it out for you, and then straight away can see the result. I mean the feedback lah, right? But the lab practical, you have to do it on your own, right? So I will share with you during practical class later. You will have some that is being done on, just to introduce to you the commands, being done in the online class, and then some that will be given to you, you do as homework. Okay, you do it on your own, right? And then of course I will provide a place for you to upload upload. Okay, and we'll put in the due date as well. right? Depending on when I give it to you, and then maybe probably it's the next week lah. So that's why it's submission of weekly submission, right? Okay, so coursework assessment for computer networks. There are two. There's one of it is tests. Okay, covering chapter 1 to chapter 4. Okay, later we'll see what are those chapter. Yeah, and it's going to be conducted in week 4, and it takes up 40%. Now, although there are fewer courses, but the courses all double up, right? So let's say this week you have another lecture tomorrow. Okay, I'll show you the course plan. You can see that it's quite a lot of information to take in, right? So, but you should be okay, right? If you keep yourself up to date, right? When I'm giving you some of the lecture, you keep up and then you revise and things like that, huh? So time management becomes very important in short term, huh? Right, and then the skill-based assessment, exactly like last time, you are using packet tracer in the assessment. It will be given to you in week 7, right? And it's form 60%, right? Right. So here it's just a repeat of what is put in MQA computing standard now, because uh, we're hoping for certification by MQA in next year. So we have to actually follow all the MQA suggested things like this here, computing standard. Meaning to say, we have practical, which is this one, skill-based assessment. Therefore, in this coursework assessment, you must pass the skill-based assessment. So you can see that the ratio is 60% out of 100, right? So to pass the skill-based assessment, which is the practical component, you must get at least 30% and above. So that's why it says here, minimum passing mark for SBA is 30%. Okay, 30% of 60% in terms of ratio, or 50%, sorry about that, 50% in terms of overall mark. Let's say the packet tracers SBA is like 100 marks. So you have to reach 50, okay, in order to pass, okay, in this course. Huh? Right, so here, some example calculation, right? Um, Student A and student B, they both got different kind of marks calculation. So let's say student A got 50 for test, 50 for skill-based assessment, right? 50-50 should be okay, right? But now we have to look at this 60-40, right? So we have to convert, right? Based on the ratio. So here you get 20%, here you got 30%, right? So for here, you meet the minimum passing marks, which is 30% here, right? So meet minimum passing mark, 50% cost, this one, right? 20, 30, 50. 30, pass this one, SBA, so pass coursework. Let's say you did very well on the test, 80 over 100, but you did poorly on your SBA, 30. So we calculate here is 32, definitely good, right? But here you only get 18, it doesn't reach 30, right? Although it meet minimum passing mark, which is 32 plus 18, right? You can see there it's 50%, but due to this one, right? This rule by NQA, the practical component, you didn't pass all. That's a different, say, course learning outcome compared to tests, because it measure or assess different things, right? So it's a conditional pass required to take review assessment, which is also SBA, until you pass, right? So no change to original coursework mark after passing the review assessment, because already passed the coursework. Okay, but you must pass. You must do the skill-based assessment until you pass, right? I'm sure you should be okay with you guys, as long as you do all the homework and also the in-class practical, it should be all right. Again, another example, right? Right. So I will share this in the Google Classroom. It's already in the drive. Actually, you should be able to access it. But go have a look at this later lah. I don't want to spend more time on this. But you can see there are different example of combination of marks. Of course, this is not limited to this lah, right? Because there are a range of marks. Okay, different student got different test marks or skill based, but it gives you an idea of how to calculate lah, right? Again, another example, right? Another example, you'll have a look at it yourself. Huh? Student coursework mark range from 40 to 49 only are eligible for make good tests, right? But of course, if you rely on the make good, you're limited to 50%. It's something that is make your exam more stressful. 50% only can, okay, to add to the exam marks for your overall marks, right? So I usually don't tell my students don't try go. Please, you basically give yourself a handicap already. Okay, you try to aim for higher, right? So 80% of all packet tracer files for is uploaded. This is second condition. You need to say you have to do, right? You have to do up to 80%. It means you submit up to 80% of all the practical exercises that for lab and homework combined together, right? And another is attendance for tutorial and practical classes. Now the thing is, I believe for us this is easy to achieve, okay? But in KL main campus, it's very hard to keep track of all the students, and if you have to give them an incentive, okay? This is actually an incentive for the student to do their, you know, packet tracer exercises, and also, for you to do well, you have to actually do the tutorial and practical. That's why this incentive is given there for make good, right? It means if you don't do this, you're not eligible for make good lah. Right. So again, just to tell you the examination wise, the format is the same. As you can see, question 1 is 25, question 2, and so on and so on. Right? Okay. You can check out if you want a preview of that, you can go to as usual, to our intranet and download the past year paper. Okay. But we'll try find some time in week 7. If not, maybe we'll try to make some time, maybe at least one or two, minimum one paper we go through to just have have an idea of what the exam paper looks like. All right. Okay. So because I believe the exam period start immediately after the week 7, if I'm not mistaken. So there's very little time for us to do revision. So if you want to do revision, you start early, Start early. All right. Again, threshold. This is the marks threshold. I think this one's similar as before. It's actually under policy guideline academic regulation for bachelor programs. Okay, so you can download that. Again, this one is calculation. How to calculate pass or fail. Right. I trust you guys will have a look at this yourself. If you're not too sure, you can let me know. So I'm just going to go quickly on this. Right. Okay, so also this one I think you know already. For bachelor, there's no C minus. C minus basically is considered fail. So rather than just showing it there, you just put fail straight away. This is bachelor. So diploma still have C minus, but bachelor don't have. So C plus C, and then that's it, fail. Okay. All right, seat token I will provide, as I said before our practical. We'll do this one. Okay, so that's it for this one. Right? Any questions?
So this week it's no tutorial yet. Or do we still have tutorial?
We have tutorial. We have
Ah.
tutorial. Yeah, no worries. We have tutorial. Uh, because we are really short of time. So we kind of luckily we tidak kena the coming public holiday kan.
Oh,
Alright,
yeah.
so yeah, luckily lah, because that one oh. Right, so let me just close this one first, and then right. Okay. Any question? Just let me know, and you can interrupt me anytime. Okay.
Just upload this PDF.
Which one?
The previous slide.
Oh, yeah. It's already inside the. Can you access it inside the Google Drive for Classroom? Click on it. You can check because I put in all the what do you call this PowerPoint. It's actually PowerPoint. Can you see it?
No.
Is it there?
No.
Click Class Drive folder, and then you go into lecture, chapter 0 BMIT.
Here. There's no chapter 0.
Oh, okay. Let me just share it with you guys very quickly. Can you see under introduction?
Is it in Google Drive?
No. You can straight away see it from Google Classroom now.
Oh, Classroom.
Under lecture introduction. You see?
Oh yeah.
Yeah. Good. Okay.
Okay. Thank you.
All right. Okay. Okay, so have a look at this. No assignment, Calvin. No assignment for this one. It will be packet tracer and tests. Okay, have a look back at the introduction slides. Yeah, that one is given from KL, right? So I just put my name there instead of the KL lecturers. Okay. All right. If you want to ask me something, just unmute yourself, or you can raise up your hand like so. Okay, so that I know, oh, you have a question. Maybe, yeah, maybe you want to type in your answer in the message box. Okay. All right, so we'll start with this chapter 1, module 2, switching concepts. Okay, let me just focus assist first. I keep coming up with the notification. Right, chapter 1 module. Oh, hang on. Let me record as well. Start to record. Okay. Right, so recorded already, yeah. All right, so chapter 1, module 2, switching concepts. All right, so the objective of this chapter, this module, I explain how layer 2 switches forward data. So we've learned about switches earlier on in FCM class already, course. and we know that it forwards packets within or frames. Okay, switch work on frames, not packets. So it forwards frames inside a local area network. Okay, switches connect hosts within a local area network. So it's never going to work outside of a local area network. So frames are forwarded. So frame forwarding, going to look at that. So we need to know, right? Sorry about that. We need to know about switching domains. Okay, so we want to why we want to know about domains, because switching domains entails to tell us whether it's a collision domain or a broadcast domain. All right. Part of the popular question and also something that you really need to know is what is the difference between collision domains and broadcast domain? Okay. And why do we care about domains, whether it's collision or broadcast? Right? Okay. So that's what we're going to look at in part of what we're going to look at. Yeah. So still remember all our network devices. Okay, just a recap. Routers connect networks together, right? Routers connect networks together. Those networks are local area network. When you connect local area networks together, okay, whether they are in the same vicinity or they are remotely connected, they become either, well, usually they become a wide area network, right? And it could be a LAN, because in the building you might have multiple LANs and then you connect them. So whenever you try to connect networks together, because each network have their own network address, right? So we need a device called a router, right? Okay, this is just a recall back, yeah. And how do you connect hosts that forms a LAN? By using a switch. So router is a layer 3 device because it works at the layer 3 of the OSI, right? Remember, network layer. And switch, okay, works at the, that means it works with, what is the PDU for data link, which is frame. Router is packet, yeah. Switch works with frame and it works at layer 2, okay? You can see here the name of the packet data units. Oh, sorry, PDU. Okay, right? Frame for switch, and then hub is what basically also connect a host together inside a LAN. It means it creates a LAN by connecting all the hosts together. But different from switch, hub is work more like a a repeater. It does not read any of the address. For example, router looks at the logical address, our IP address. Therefore, it knows how to route between networks. Switch reads the MAC address or the hardware or physical address, okay, that is part of the framer. Okay, that's how it knows how to forward a frame to which host, because each host will be connected to a port on the switch. Hub does not read anything, does not know about IP, of course, and it doesn't know about the physical address, which is the MAC address as well. So since it doesn't know, it broadcasts. Meaning to say, any bits coming in, okay, in one port, it will just replicate to other ports. Okay, because it doesn't know, so it basically is a broadcast mechanism, right? Physically, it looks like a switch. Physically, seems like it works like a switch, but internally, it doesn't work like a switch. Switch will make the switch connection between this port and that port, depending on the destination address, right? But hub, since it doesn't know addresses, it will just replicate to all the ports, which means it will broadcast. All right. So that's just a recall for you guys. Right. Okay. So next section is frame forwarding. Right. So look at switching in the networking. So we introduced to you two two terms. Okay. One is ingress and one is egress. Okay, this terminology is very popularly used in networking. Network engineers or network literature will talk about ingress, egress, right? So it's maybe not used in daily conversation, but it's normal in networking. So what does it mean? Ingress means when you're referring to those switch frame entering the interface or the port, coming in into the device. So we call those the ingress interface or port. I hesitate to say interface because usually I reserve interface for the port that has a logical address. Okay, normally for switch, I will just prefer to call it a port, right? But ingress and egress, although we're talking about switches, also can be used in terms of the intermediate device like routers. So ingress is entering, okay, entering into the device. Egress is when it's exiting the device. Okay, so when data is coming in, we call that ingress. Going out, egress. All right. Now this become important because sometimes we want to differentiate between coming in, going out. Right. Okay. Right. So inside the device, in this case, we talk about a switch. Right. We will a switch will look at the switching table, the table inside that maps the MAC address against versus the port, right? So you can see the port table there. Destination address, of course, this is already truncated. Of course, for the real port table, you will have the complete MAC address there, right? And of course, the port number. Okay, so this port table is populated dynamically. If you still recall, it's dynamically populated by the switch. So you don't, as a network administrator, you don't have to worry about, oh, I have to edit the port table, insert the, I mean, you can, but it's not advisable because there's a perfectly good algorithm that the switch is using to populate the port table, right? So a switch forwarding activity based on the ingress interface and the destination MAC address. Why ingress? Because if the frame coming in from the ingress interface, you know straight away if the source address of that frame indicates what is the MAC address that is connected to that port number, right? So that straight away you can dynamically update. Oh, I know this port number. I see a data ingressing, a frame ingressing from there. I look at the source MAC address. Straight away know, okay, that PC or that host has this source MAC address. So maybe that one is port 1. All right. So I update my port 1 table, map to what is the MAC address, and then to egress means I need to choose which port to forward it through. So I look at my my port table and I check because I see the frame's destination MAC address. I open up and see, oh, okay, so this is AA. So I look at the table, what is AA? Oh, port number 2. So I forward it to port number 2. What happens if there is none found? If none is found, there's no choice. I will call it flood. I means I will, except for the ingress, I will broadcast it. No choice, the port table doesn't have that MAC address, so I have to broadcast it, but then not the ingress because I know it came from the ingress, cannot be there, right? So then later, when because it will be ignored by the host that does not have that MAC address, but the host that have that MAC address will then send back a reply when it's coming in ingress again. I check it, and then the source address, I will then update my port table. That means it dynamically updates. So next time, I don't have to broadcast anymore because now I have the entry of the MAC address in the port table. This is how the switch dynamically update its port table, right? Okay, port table or MAC address table. Okay, so you can see the note there. The switch will never allow traffic to be forwarded out interface. It receives the traffic. Of course, because it ingress from there, you know that cannot be, cannot be. Remember, if you use a local host or a 127.0.0.1 address, if you're sending a message to yourself, exactly right. It does not leave your machine, so you cannot make argument that okay, maybe the host is sending a message to itself. Cannot. So that means anything coming in from the port where that host is, that means it definitely going to address to some other host, not back towards itself. So that's why the note, a switch will never allow traffic to be forwarded out from the interface the traffic is received from the ingress. Okay, so all the egress ports, okay, will be used to forward, but not the ingress.
So can
Okay.
can this thing can they have multiple ingress and multiple egress port? Egress
Not for
interface.
not for one message. That means from different hosts, possibly, because that's how network works. But a single host will only be attached to the switch using a single port.
Also, but it still can get multiple in ingress and then it
Can.
still
Okay.
okay.
Yeah, imagine this, Kelvin. Let's say you have two network cards, but your two network cards each have two different MAC address, correct? So if you attach two cables, one in each network card, and then you attach to two ports, so you can send to yourself, but of course, when you send to yourself, you'll be using the other network card's MAC address. So it's still logical, right?
Yeah.
They just be switching back to you,
Okay.
right? But I don't know why you want to do that, because the faster way is using the local host. You don't even have to go out of your interface, right? Okay, but it's possible. It's possible. The usual way is actually one of the interface go to one switch, one of the interface go to another switch, and this switch connect to two different networks. It connects to a router. This one connects to a different router. Then that is a more typical if you say that the host have two network connection. Okay. Yeah, but if it's single network card, single port, then one ingress only. I mean, from that host. Egress means it's going to be forwarded to, normally it's one-to-one, but during broadcast or when the port, the MAC address table is not updated, then broadcast will be used. Okay. So you can see the switch will use the destination MAC address to determine the egress interface. Okay, so basically, let's say I detected AA as a destination address, and I go into this MAC address table. I see AA is mapped to port 2, so I know I forward the frame to this port, and it goes out that, and then it will go through the cable connected to this port, go to the host, right? Before a switch can make decision, it must learn what interface the destination is located. This one I described earlier on, how the switch dynamically update the MAC address table. Any data ingressing will be opened up, right? Layer 2, look at the PDU, the header, open up and look at the source MAC address. If it doesn't exist in the MAC address table, the switch will then take that MAC address, source MAC address, and put it as an entry for that particular port, right? So that's how it's populated. right? So a switch builds a MAC address table, also known as CAM, right? So this is another way, another terminology similar to MAC address table. Sometimes you read in literature, it's called content addressable memory or CAM table, right? Okay. Right, so it's a two-step process. Learn from ingress, always examine source address. Okay, so then the switch know definitely that host source MAC address coming in from that port. Then I enter into the CAM, right? All right. Okay, so it says here resets the timeout setting back to 5 minutes if source is in the table. The thing is, sometimes people connect, people disconnect, some other people connect, disconnect. So the data inside the CAM table will be what we call stale, outdated, obsoleted. So we always have a timer to forget, okay, to forget the content of the table, right? This to ensure that because let's say you unplug and you plug a different machine there, okay, different MAC address already. So if the switch doesn't know how to forget the old address, it will, that means it will fail already lah, the next time, right? Right, step 2 is forwarding. So ingress, then egress. Forwarding means it egress. So for forwarding, the switch examines the destination MAC address, right? Okay, so if we cannot find in the CAM, then no choice, because the switch doesn't know, it will broadcast. It will broadcast means all the egress port, the switch will send the frame through. Okay, that means hosts that do not have that destination MAC address will ignore, but the host that will have that MAC address, that destination MAC address, will send back a reply. Okay, and when it sends back the reply, then you can then update. Because again, it becomes an ingress, right? Then you do the step 1 to update your CAM table, and this is repeated every time. Okay. All right. So as I said, this video will cover build MAC address table, how switch. This is exactly what we have been discussing. I'm not sure whether there's a video here, but I'm pretty sure there's a video in the what you can view later once I activated your net cap, okay, with the token. Right, so basically it's a video or animation that shows exactly what we are talking about Right, so switches use software on ASICs to make very quick decision. Right, ASICs is very special purpose IC integrated circuits. Normally we do right, because it's faster. It's faster. You remember, latency of the network includes the switching part of the latency introduced by intermediate network devices. Okay, we talk about latency means there's a slow part of network right? You talk about the speed data transfer speed or broadband speed or whatever speed, right? Bits per second, right? 10 megabits per second, 10 kilobits per second. Okay, but that's on the line. Okay, the latency includes, that means you have to add in additional slowness to the network, where the data have to go through all these network devices like switches, routers, right? So if you want it to be fast, you have to make the switch work or operate as fast as you can. Again, this one depends on the budget the more expensive switches, not only you can manage the switch, but you can also ensure that all the integrated circuits there are actually there to very fast lah, right? Because if it's slow, it adds on to the latency in your network. Right, so we look at two methods for forwarding decision, right? This is how the switch operates lah, in terms of when it receives a frame, what does it do? How does it, what kind of technique it does to forward the frames? Okay, so the first one, store and forward switching. Well, basically the switch will accept or receive the entire frame first. Okay, that means if the frame is how many, what size, it received everything. Then it will use, remember the trailer part, there is an FCS, there's a checksum inside there, right? You need to receive the entire frame, then you can open up the trailer part, extract the FCS, recalculate using a checksum, CRC, right? Okay, where you will enter the whole bits into the function and you perform CRC on it. Then you compare the value you get from performing that with the FCS value. Okay, if it's the same, valid, there is no corruption, there is no interposed bits or missing bits or whatever, right? Okay, so what happens if there's corruption? The frame is dropped, simply drop. The switch doesn't do any error correction. The switch just drop it. Where is the error correction being done? If you recall in FCN, it's at the transport layer, specifically under TCP. TCP is waiting because there's a connection, right? It's a stateful connection. If it times out, it can don't receive any reply when the host send it. Then it knows there's a corruption happen. It's lost. It's lost how? The frame drops it. Because why? The CRC check fails. Right? So store and forward switching actually is part of the checking for the frame and of course the data, including the packet and all this thing, right? Okay, so in the TCP, in the transport layer, they just, okay, resend again until timeout. If really everything is every time drop, that means the network condition is so bad that at the transport layer it never received any acknowledgement, right? So that's when it bubbles up the error to the application layer, and you will see the error, network error message. Anyway, it will try multiple times until the certain period of time that is configurable elapse. Okay, then it give up lah. But as long as not reached that, it will try to, send and retry lah, right? Okay, so who checks? Of course, here this store and forward switching method, it checks the frame with the CRC check, right? But you will notice that this is slower. Why? Because you have to wait until you grab the whole frame, then perform the CRC check, compare the two values, the one you calculate at the switch and also the stored value in the FCS field. Check it, equal, valid, not equal, invalid, drop. Okay, so is there a faster way? The second way there, cut through switching, is faster. This one doesn't check. Excuse me. It will forward the frame immediately the moment it detects the destination MAC address. The destination MAC address is part of the beginning bits of the PDU header. Excuse me, I'll just read first. All right, so it received bits coming in, part of the frame coming in from the ingress port. It's straight away the switch start checking already. As long as it checks, okay, I got the destination MAC address, straight away I know already the MAC address. I check my CAM table quickly, then I know which port already, or which ports if I don't have it inside my table. So straight away start sending the bits towards that port, identified port. Okay, so this is faster. right? This is faster because it doesn't have to wait until I get the whole frame, perform the CRC, compare the CRC with the FCS CRC, then check whether valid or not valid before I decide to forward. But this cut-through switching, straight away check for the moment it sees the destination MAC address, it can straight away start forwarding already. Okay, now then you might ask, hey, how come cut and through switching, isn't that dangerous? In the sense that what about if there's corruption? Yeah, that's why cut-through switching is only used in a very stable network. If you trust your network, you are the network administrator, you can set whether it's store and forward or cut-through switching. If your switch allow you, or you got options to do this lah. So if you think your LAN, okay, you do some testing like your network engineer can, and your LAN is stable, very hardly you got corruption. Then you say, oh, make it even faster, do cut-through switching. Right? Right. So the store and forward has two primary characteristics. So you can see the store and forward just now waits until the whole frame is received via the ingress port. Okay, this is what I was talking about, CRC and the FCS, the frame check sequence, right? So if you receive and you check, there must be somewhere you temporarily store the frame. Okay, so that's called the buffer. So we buffer it, so buffering, yeah. Okay, so you can see ingress interface will buffer the frame while it checks the FCS, right? This allows the switch to adjust the potential difference in speeds between ingress and egress port, right? So if there's a difference in speed, one is sometimes the ports supports different cable, different speed, different, things like that. So if you use this store and forward, you can use the buffer to to adjust the speed lah, right? To adjust the speed of the. But that means another thing is that the store and forward switching, you really need to have buffers, right? And the size of the buffer means will affect the performance of your switch lah, right? Right. So right. Let's go to the next one. There's a cut-through switching. We talk about how we speed up the switching process by not checking for validity of the frames, right? The moment we get the destination address, we straight away know the port, we send through it. If not, we straight away do the broadcasting already. Right? Right, so there is still a check that it does, a very least. It's called the Fragment or Frag free method. Right? All right, so this one ensure that the frame is at least 64 bytes. If it's less than 60 bytes, it is considered an invalid frame. And this invalid frame has a special name. It's called runs. Okay, runs. So basically just checking that at least it's not less than 64 bytes. So at least it will receive from the ingress 64 bytes and then start sending off. If not, what happened? I think it will also drop it, right? Okay, so again, this is very quick. So it's very, very useful if your networking requirement, okay, you don't want too high the latency. So you can see there, the switching needs, maybe you want under 10 microseconds. That's very quick. 10 microseconds, very quick. So if you want this kind of switching speeds, then you might want to do this cut-through switching. But you must have a network cable to match, right? As you can you have probably remember from last time we talked about network cable, the higher category Cat6 and Cat6E, I think, and also STP type of cable are very, very stable, right? STP, remember the shielded twisted pair, right? Shielded twisted pair also prohibits EMI or interference, right? Not only the crosstalk with the twisted, but also the shielding, right? So that means why you want to do this? Because you want to eliminate all potential um, corruption happening while the data is traveling through the cable. So that means you're providing very stable. So if it's stable medium, means the switch doesn't need to do any error checking. So you can do this cut through switching, right? Okay, but if you never got problem, that means it's not stable. You're using lower class cable, cheaper, right? But then potential for corruption of the data is higher. Then you can see this part may lead to bandwidth issues if the switch propagates too many errors. Of course, when the switch forwards it to the receiver, the host, the destination, okay, they will check the frame also, and then it will drop if there's an error with the frame. Okay, if too many errors, okay, the TCP will also not receive acknowledgement, and so the TCP will delay network communication. You'll find that the resend until you give up is actually you experience it as laggy network lah. Lag. That's why bandwidth issues. You find the network slow, the latency too high, right? So this one actually must be matched with a very good or stable network medium lah in the LAN, right? So I don't think you can use this with lower quality cables lah, right? You have to use good quality cable. Okay, good quality cable is also fast. Then coupled with this fast, then you can easily meet your network requirement for fast network, right? Right. So this one don't have buffer, so you cannot adjust between ingress to egress. That's why it says here cannot support ports with differing speeds. Remember the other one, the store and forward, it has buffer, so the timing of sending from ingress to or switching from ingress to the egress can be done by the switch, right? But here, because there's no buffer, it's just straightaway transfer. Then there is no timing capability to forward from ingress to egress. So that's why it says cannot support ports with differing speeds. Okay, differing speed between one port and another port. Okay. All right, so far okay or not? Noel and Calvin?
Okay.
Okay.
Kevin? Okay, all right, good. Okay, so let's look at switching domains. Recall back, I talked about the collision and the broadcast domains. What's the difference and why do we care about this domain? Okay. Right, so first let's look at collision domain. Collision domain sounds very bad, collision, and it is very bad because when collision happens, just like in normal road, if there's collision between cars, traffic jam will happen. Not only there's maybe some people get hurt and that's bad, right? But you see the traffic flow will be will be congested already. Okay, traffic will be backed up, and then you need some police to come in and clear up the site and the collision site. So the same with networking. When collision here means the frames collide lah. Right, when it collides, it means it introduced corruption. It will all the frames will be dropped lah, right? And then have to wait until the medium ready to send the next frame through. And of course, at the transport layer, there's no acknowledgement, so TCP will resend until it gives up. So that is a lot of latency there. There's a lot of slowness there, laggy already, right? So collision domains is eliminated by switch. Remember, collision happens with CDMA, I think. Yeah, the old type without switch. You know, those Ethernet, just single Ethernet line, and all the computer connects to it, the bus network, right? That one we have to collision detection and and you have to resolve it, right? But with the switch, because the switch will just very quickly switch connection between one port to the ingress, egress. That means there is no collision can happen, right? Because unless the switch wrongly switched, but I don't. If the switch is working properly, you look at the MAC table and the port should be working fine. So it's basically just like a telephone connection. The switch connect you to the correct number. Then when I talk, I don't find myself talking to a different person at the same time or whatever. It's physically switch. So here, the switch also physically switch, basically making connection. Let's say you have these two lines. You basically making a connection, physical connection, a switch, right? Then you conduct the electricity coming from one cable to another cable, but only between these two cables connected to each port, ingress, egress, right? So you're physically making connection. There's no way you can have a collision with other ports. So switches eliminate collision domains, reduce congestion. Collision domain simply means in a domain, collision can happen, right? So if you have a switch, collision domain becomes smaller. Okay, smaller. Right. So that is reduce. Can reduce. When you say eliminated, no such thing as collision anymore. So especially when you use full duplex, remember the Ethernet cable, how many wires you have inside? I think the 4 pairs. So add wires. So a pair of wire is I think send. A pair of another wire is transmit and receive, right? So they are operating independently. So that means a full duplex. You can be sending a message but receiving another message, right? So that's the good thing about Ethernet cable, the modern ones, right? Not coaxial. Coaxial is the one that is on the old Ethernet network, and because there's basically just a couple of wire connected together, then of course messages will collide if both more than one host send at the same time. But with switch, right? You could be receiving, the switch happen very fast, right? You could be receiving a message, you could be sending a message at the same time. So this is what we call full duplex, right? Full duplex, you never get collision, right? When there is one or more devices in half duplex, then it will be a collision domain. Half duplex means you can only send or receive at any one time. You cannot have both at the same time, right? So there's a potential because they're using the same pathway to send, to transmit and receive. And there's a potential to have the data collision, right? So half duplex is prone to data collision, which is collision. That will be a collision domain. Also, there will be contention for bandwidth. Collision possible. So you can see when you have, like, for example, Cisco, right? When you have full duplex, and then you connect the port. One port is full duplex, the other port is full duplex, right? normally we have auto negotiation. This is configuration for the port, right? So by default, Cisco and both Cisco and Microsoft. Why Microsoft? Because at the PC side, the OS usually is Windows and is by Microsoft, and the device driver is under Microsoft. So that means the NIC or network interface card is under control by the Microsoft Windows, right? But inside the switch is Cisco iOS. So Cisco is the one in control of that port on that switch. Okay, that's why it's Cisco Microsoft. Okay. Anyway, both of them usually typically use something called auto negotiation, right? For as a default setting for duplex and speed. Auto negotiation means it's auto detect whether it's duplex or full duplex, adjust accordingly lah. All right, and of course the speed will go down when you go half duplex. Okay. Okay. Let me know if you need any extra explanation. Yeah. Okay. Right. Just now collision domain. We talk about places in the local area network where collision can happen, right? So this one we talk about broadcast domain is when you send a broadcast. What does it mean? It's one to all, one to all. So one host send a message, the switch will propagate to all ports. All other hosts will receive that message, right? So why we care about broadcast domain? Because it's a small LAN, not a big issue. But what if you expand your LAN? You can see on the screen, the first LAN is a smaller LAN, typical switch, multiple hosts connected to the switch. Let's say you want to expand, you want to scale, but you don't want to buy a router. Oh, you can. Just connect one port of the switch to another switch. That means you can see there from switch 1, okay, switch 1 to switch 2. I wonder how come I cannot highlight. Hang on. Can I highlight or not? Laser pointer. All right, here you go. Here. Okay, oh, sorry. Here, switch 1. I want to scale. I don't want to buy a router. I want another LAN number 2. So I buy another switch. Switch is cheaper than router, so it's okay. All right, in my budget. So how to connect? So I just plug in into one port and then plug another port in switch 2. Then these two belong to the same network. Same network, but check out, right? So now let's say this server wants to broadcast, okay, the initial network. It will broadcast to this PC, this PC, this PC, one to all, right? Okay, so let's see whether when we scale up and we can extend this, we call that extended star topology. Okay, we just keep expanding, right? So, but the thing is, if you consider where the broadcast can reach, is where we consider it as a single broadcast domain, right? So now, let's say this server wants to send a broadcast. It will send to here, yes, and this port also. So this port comes to here. Again, because it's broadcast, so you'll send here. And if you have more connection, extension, again, it will just propagate to the entire LAN. Now imagine, that is one computer sending a broadcast message, right? Now think about, is there any reason why you want to send a broadcast? Yes, when the switch is trying to build its MAC address table, or when you want to send a broadcast message, of course, but typically ARP, remember ARP, address resolution protocol? Okay, because you don't know yet, because your host, you don't know yet what is you have the IP address, you don't have the MAC address, you have sent ARP, and ARP is always broadcast. Okay, and then since we connect all the switches together, then it will go all, so the whole entire thing, okay, within the same LAN, same network address. Okay, that is the broadcast domain. And you can see the more you scale up, that means the more switch you add, the more host you add, okay, the more of the computer might be adding into the broadcast domain, then you can see that it will start to flood more. Okay, broadcast will take more and more of the bandwidth in your network. So it's not very scalable. That means in terms of performance, you see that if you just simply add on, all right, that means you're starting to become an enterprise network. Okay, it's not enough to do something simple anymore, the network, because it suffer from this problem. Okay, this flooding. Okay, flooding of broadcasts inside the broadcast domain. So you can see here, too many broadcasts may cause congestion and poor network performance. Right? So layer 1 is hub, layer 2 is layer 1 is hub. Hub is memang broadcast. Everything you send through the network will be broadcast. No choice for layer 1 hub. Layer 2 switch. Okay? Any broadcast message will also propagate. So increasing the devices like either hosts or the switches or hubs will enlarge or expand the broadcast domain. Broadcast domain is simply where if I send out a broadcast message, it will propagate to the entire broadcast domain. Right? So can you see the difference between broadcast domain and collision domain? Collision domain is a way for us to say, okay, in this domain, this section of the network is where collision can happen. And then broadcast domain this is a section of the network or part of the network where if I send a broadcast, it will propagate to the entire domain. Okay? Right? All right. Okay, so this exercises is very, very popular. Now, I don't know why it's the blue thing there. I think if you open your PowerPoint, I open in Google Slide. That's why it's the blue slightly go and do that. Anyway, broadcast domain is only stopped by router. Why? Remember the rule for router? Router connects networks together. Okay, and router will stop any broadcast. Okay, router does not propagate or does not forward broadcast message. Why? Because the internet is basically made out of small networks connected by routers to become a wide area network. Right? And the largest wide area network is the internet. Can you imagine if router starts propagating or forwarding broadcast messages? Pretty soon the entire network, the entire internet will be full of broadcast messages, and it just performance will really be going down. Right? So in order for you to know, okay, what is my broadcast domain? Check the network that is connected to the router. Right? So in this case, you can see there. Right? So there's one network here. There's one network here because two network interface at the router. So one network. So each LAN is its own broadcast domain. Right? So let's check again. It's very easy to find out what is the broadcast domain. Broadcast domain is only it will only be effective in its own network. So when you look at the router, check. Okay. how many networks connected to it? So we can see 1, 2. So that means there are 2 LANs, which means there are 2 broadcast domain. Okay, so any broadcast here will be stopped here because the router do not forward broadcast packets, right? So that means it limits here lah, broadcast domain. How are you going to draw the circle? Right? Make sure you draw. In fact, this one is purely drawn. Make sure you draw like here, encompassing here to indicate, okay, this is the one, then draw like that until here. Something like this lah. Kasih ngam-ngam lah, kasih ngam-ngam like that. Okay. Okay. That's how you draw the domain. Okay. So this is broadcast domain. So the second type is the collision domain, right? Now collision domain can happen where? If you have a switch, this is a switch, this is a switch, it only happened in the segment, okay, between the switch port and the other device port. So here is router, here is switch. So the collision domains can only happen here. Okay, because it's not going to collide with this because the switch handles that, prohibit that. Okay, which means, and it can only happen if it's half duplex, basically half duplex, right? Half duplex. It's full duplex. There's no, it's eliminated. No collision at all. But we can consider some devices are half duplex or some interface are half duplex. If one part of the medium is half duplex, okay, the other port, even if it's full duplex, will have to follow with the least capability, which means it will become half duplex. This is what the auto negotiation is for. Yeah. So in your network, if you want full performance, okay, you must make sure all the ports support full duplex, or else that collision domain part will just follow the other port. The other port is half. Okay, I although I know how to become full duplex, I just also follow half duplex. Okay, right. So you can see, the best way to draw is actually just here near the port like that, not extend. I think this, because of conversion by this slide, Google slide, not so good, right? So it's based on the port-to-port collision domain. Now look at the third example. This is hub edge. Okay, this is routers, right? So if routers are, how do you know it's collision domain? Again, port to port. Okay, and then routers to switch, port to port. Okay, switch to host, port to port. But then hub is very similar to the old bus network, since hub is broadcasting. It's not switching. So hub potential to have collision is the entire area or segment of the network that the hub serve. This is the entire collision domain. So you can see collision domain is actually bad. The smaller, or if there's none, it's better, right? That's why if you can afford switch, you won't buy hub, right? Collision will give you network latency, network slow down, so you don't want collision. But hub, look, the collision domain is the entire segment of the network that is serviced by this hub, isn't it? So switch is only between port to port. You can see that, this one, port to port. Also the router and the what lah?
Are the blue circles broadcast domain, while the red circles are the collision domains?
The red circles here are the broadcasts.
Oh, the red circle are the broadcast.
In this one, the third diagram here.
Oh, the third one.
So yeah. The red ones are the broadcast domain.
Oh,
The gray, is it blue or gray?
the blue.
Is it blue?
The not red one.
I look at it like a gray. Anyway, the red ones are the broadcast domain. So see, anywhere inside the red is the broadcast. If I broadcast from this, it goes all over here.
Oh, okay.
Usually, you notice the broadcast is how many networks you have from the router. 1, 2, 3. So for this network interface here, this is one broadcast. Then here again, second broadcast.
Also different route from the router is one broadcast.
Yes.
Okay.
Yes. So one network, one broadcast domain. Okay. Right. So, but for the collision domain, you have to look. Okay. For switches and routers, each port to port is one collision domain. But for hubs, the entire segment served by the hub becomes the collision domain for that hub. Okay, that's the thing that you have to watch out for. All right, and there will be question asking you about this lah. If I recall, even the tests they will give you certain scenario like this. Ask you question like, can you calculate how many broadcast domains are there in this diagram, or how many collision domain are there in this diagram? Sometimes the question will ask you, can you circle the collision domain? Can you circle the broadcast domain? Something like that. That kind of questions. Right?
Does the hub function as an extension?
Yeah. It works as an extension to the switch. Means you just created extended star, but instead of with a switch, the secondary device is just like it's a hub. Okay, a hub is at layer 1. It does not understand address, which means if it doesn't understand address, it doesn't know which port. So it will just replicate to every port in broadcast. That's why the broadcast, you see, every message coming into ingressing into the hub doesn't know which port. So it will broadcast. Right? It works by broadcasting frames. Oh, bits, sorry, because it doesn't even understand frames, so it's bits. Layer 1 hub. Okay, right. So hub is cheap, actually very cheap. If you look in Shopee, but maybe if it's still there, if it's not obsolete, it's very cheap compared to switch. But it's cheap because for a reason, because it's not actually good. Even for your home network, I don't think you should use hub. Right. All right, so you just use MAC address table and full duplex. Remember, full duplex eliminates collision, avoid congestion. So again, I want just to say, if this is full duplex, right, you won't even have a collision here. But in this kind of exercises, we have that circle there just to indicate sometimes it's half duplex, right? Right,
So means if it's full
duplex, sorry, Noya?
Full duplex, no need to circle.
Yeah, no need to. Well, the question will never. I checked before. It never asks. It's never tell you it's full duplex or half duplex. So you always assume it's capable to be half duplex. So simply just circle. But for real world, then you know that if you are a network engineer, you never buy half duplex port anymore, right? All the newer switches, newer PC and IC will all be full duplex, right? Nobody will buy half duplex anymore. These are all obsolete. But saying that, there are some companies reluctant to upgrade because of budget. They're usually like this. Those companies If it's not broken, don't fix, don't. Okay, they want to hold on to their assets lah, right? As long as possible. So in some companies where very traditional, they don't simply upgrade. You might still find hub duplex. Okay. Okay, modern companies they probably don't have lah. If you buy new ones, new models also don't have hub duplex. All right. In the table there, you can see the features that actually alleviate congestion, means can reduce congestion. So fast port speeds, okay, maybe the port of the switch can go all the way to 100 gigabits per second. Fast internal switching, the mechanism inside the switch, right? If you're using buffer, then it's a very fast memory, okay, and the connectivity between the port to another port, we call it bus, is very fast, okay, very fast kind of internal wiring, okay, and then large frame buffers means you can store more of the frames, right? You can see there, allows temporary storage while processing large quantities of frames. Okay. But of course, all this means extra hardware, extra everything becomes more and more becomes more expensive, right? And then high port density means you have many ports. Like sometimes you reach 24, 32. One thing I noticed about switches are the ports. They always they will start with the minimum is usually 4, kind of cheapest you can get, and then they always power 2 lah. So 4 and then 8 and then 16 and then 32, right? And then I think that's it. And then if you want, you can stack the switch together, connect the switch between switch, right? One thing I noticed for Cisco switches, certain switch they have gigabit port speed, usually reserved for connectivity between switch to switch or switch to router. Why do you think? Because computer to switch port, okay, is only between one PC and a switch. So I doubt that you can, if you 1 gigabits per second is more than enough, basically, isn't it? But switch to switch means you're carrying the whole of the network from one of the switch to another switch, or from the switch to a router. So that means 1 gigabits now is shared by multiple hosts. So usually the port between switch to switch and switch to router is higher speed lah, normally 100 gigabits per second, so that the bandwidth it doesn't throttle the connectivity between this part of the LAN to the router, or this part of the LAN to another switch LAN. I mean, it's same LAN, but communication between them is not limited by the bandwidth between the two switches, right? So usually we use faster ports to connect two switches or switch to router compared to switch with host. You guys get this part? So that means yeah, means from this computer. So let's say this computer. Oh, sorry, this one. This computer to this switch is not sharing the bandwidth here. So 1 gigabits per second, fine for the computer. And then this connectivity from this switch to router here, if still 1 gigabit per second, but now this bandwidth is shared by this, if they all want to go to router, right? So usually we have this one faster speed. Okay, faster speed compared to host and the device. Okay, device must be higher speed compared to host device. Okay, this is a way for us to provide more bandwidth lah. Okay. All right, so I think fast internet switching, large frame buffers, high port density is okay. Right. All right. Module practice and quiz. What did you learn in this module? Frame forwarding, ingress, entry, egress, exit. Entry into what? Into switch. Okay, the switch builds MAC address table to forward frames on the LAN because switch connects hosts together to create a local area network. Okay, switch dynamically creates the MAC address table based on the ingress and ingress port. Okay, and the egress is always checking the table to know which port to egress from. Right, so there are two methods switch may use in forwarding frames: store and forward, where it actually checks validity of the frames, and cut through method, where it just read enough of the frame to get the destination MAC address before proceeding to forward it through the port. Right? Okay, so Ethernet ports. If the Ethernet port is half duplex, then you create port to port there, collision domain. Okay. If one port is half duplex, the other port, even if capable to be full duplex, will drop down to half duplex. Both half duplex, then only single communication at a time can happen, either send or receive. Okay. And if they somehow send at the same time or something like that, then it will be collision. So if you want no collision domain, you have to use full duplex. All right. All right. So how does the switch perform in a broadcast? So for broadcast, the switch will take the frame from the ingress port and flood it out all the egress port except the ingress port. Right? So broadcast domain exists within the LAN, okay, and is stopped by the router connected to the LAN, because routers do not forward broadcast messages. Right? Switches extend broadcast domain, but switches can stop collision domain. So the collision domain is only between port to port, port of one switch to another switch, or port of a host to the switch. Okay, it will limit to that, basically that segment, the collision domain. All right. All right. So, but switches, if by how does it eliminate collision domain? Is by having full duplex, right? All right. Okay, so I think that's it for this. So I'm just gonna show us back this one. So I talk about this first. Okay. So switching over to your course plan. So basically, we already covered chapter 1, switching concepts. Okay. And we have another lecture tomorrow, which is this one. Right? Same time. And that will cover chapter 2, which is virtual LANs. Okay, virtual LANs. Right? And as you can see, we have only 7 weeks. So every week we will cover different chapters. So virtual LANs is large chapter, so we split it into 2. First part in this week, second part in the first lecture of next week, and then after that we cover VLAN routing. Virtual LANs basically is a way for us inside the same LAN to segment the LANs so that we have more than one LANs. But it's not physical, it's created logically. But we maybe need to connect those different virtual LANs, right? So that's why we have chapter 3, inter-VLAN routing. How do we route from one virtual LAN to another virtual LAN we created inside our LAN? All right. Okay. So and then after that, in week 3, we're gonna cover spanning tree protocol or STP. Okay. STP is a protocol based on algorithm, spanning tree algorithm, to prevent circular path inside our network. In trying to provide redundancy, we might connect one switch to another switch to another switch, and they all form a circle, right? In practice, that's good. But what happens if it becomes, that means the forwarding becomes a circle, right? So we want to, in the first place, why do we want to have that kind of connectivity? Is because to provide, how to say this, redundancy in our network lah, right? If we have redundancy, means if this part becomes congested or down, we can use another path, right? But then if we want to have that, sometimes the path becomes a circle. So that means our packet, our frame just go pushing, circle, right? And we don't want that also. So what do we do? So we have this spanning tree algorithm, and it's implemented as a spanning tree protocol or STP to our network to prevent that from happening, but still have the capability to have redundancy in our network. Best of both worlds. So in chapter 4, we're going to look at that. Okay, we're going to look at that. And then week 4, after that, we're going to look at Interchannel. Okay, Interchannel, basically a way for us to combine, let's say you don't have 100 gigabits per second between two switches, but you want to add bandwidth there because you know it's shared by other hosts. So what can you do? All right, so we can combine, let's say I dedicate 2 cables, 2 ports on this switch, 2 ports on that switch, like, and then I will say to myself, hey, how nice if these 2 cables from this switch and that switch can combine to share the work to transfer data between these 2 switches. Yes, you can. So if we are going to use Interchannel, right? Interchannel, and FHRP concept is based on that also, right? And then after that, we have basic routing you want to do, right? And with routing, we have EIGRP. This is basically routers talk to each other. Okay, so we're going to look at that in chapter 5. We look at LAN security concepts, then and then we look at switch security configuration. How do you, for Cisco network, it doesn't work on plug and play switch, only works with the switch. It can be configured like Cisco. And then how do we configure the switch security? Okay, switch security. Finally, in week 7, we're going to cover wireless LAN concepts and configuration. And that's it. So you can see there also the practical side is the skill-based assessment in week 7. In week 4, midterm tests. Okay. All right. Any questions?
So far, no.
No, all right. So, all right. So now it's 3:15. Our next class is at 3:30, right? 15 minutes. Okay. All right. So we'll meet each other again at 3:30. We'll use the tutorial meet URL. Is that okay? In the meantime, we'll have a
Okay.
15 minutes break lah. Okay, so I'll see you guys in the tutorial. Okay, Kelvin and Noel.
Okay.
Okay, I'll see you then. Well, let him do it after he see the recording. Anyway, you can access it from your tutorial in Google Classroom. The first tutorial participation question. You can see the questions allocated to you. Try to answer that, right? And if you want to try on your own, yeah, I also shared the PDF version. I will upload the rest later. For now, the tutorial questions PDF, I've shared two tutorials, T1 and 2. But I need you to answer the participation one, yeah? Right? Yes, I see both of you already in. All right. So I will give you half an hour to answer, and then I'll start checking each question. Of course, I'll be monitoring. You can let me know if you have any questions, okay?
Okay.
All right. Hello. So E1 Kelvin. Switches use the MAC address table and full duplex to eliminate broadcast domains and avoid congestion. Okay. It's actually to eliminate. You can see the problem is that one.
Oh, the breaker.
No, this one, broadcast domains. It's not to eliminate broadcast domains. It's to eliminate collisions. You eliminate broadcast domains only via router. Only router can stop the broadcast domain. Yeah. So it should be to eliminate collisions. Then
Oh, okay.
yeah. Okay. So broadcast domain is actually stopped only by router. Okay. The MAC address and full duplex is for collision domain lah. Right? Okay. Let me just put it there. Or maybe eliminate collisions rather than domains. Okay. So this one is the so okay, so correct the ingress port and destination. Okay, so IP address is for layer 3. Yeah. Number 3, explain how switch builds its MAC address table. A switch will use the destination MAC address to determine egress interface, correct. But this one is for, it must learn, okay, so right, must learn before a switch can make this decision, it must learn what interface station is located. What interface station is located, okay. Switch will recording the source MAC into the table of the port it was received. Okay, number 5. F5 is correct. F5 is correct, okay. Right, because destination is 0C. 0C is located or mapped to fast Ethernet into port FA5, correct. Explain how switch ports frame to destination. Switch will check the MAC address in a MAC table. Matches function, okay. This one is correct. Yeah, that's correct. Okay, Kelvin, don't forget to add this one, number 1. The switch receive, for example, here, the switch receives frame through FA9, right? And it will add the source MAC address to the switch MAC table. Include that one. So this one will be 1 mark. Okay, so maybe not use that. Okay. So all 3. Okay, don't forget this part. This one 1 mark. This one will give you 2 marks. This one will give you 2 marks. 5 marks altogether. Okay.
Okay.
Mm. 6A and B. Answer question will provide figure 2. Well, without error. Explain how the switch holds a frame to the destination. Okay, so this is about the same. Okay, so receive the frame. Okay, just be specific. Through FA7. MAC address, yes. And it will add the source MAC address to the switch. The interest was used for the sample. Okay. Technology is so I can compare. Okay, so what happened if there's none? So destination is OD, right? Okay. Right? Sorry, source is OD. Destination is 0B. 0B is not there. So Noel, you explain the answer correct, but it's for match, right? So can you amend your answer, Noel? If there's not a match, what happened? Because there is not a match here.
Oh.
Yeah. So you can see there the destination is 0B, whereas the MAC table don't have 0B. So what happens then? Okay. Amend your answer. Your answer is correct if there is a match in the table. Okay. FM. Okay, discarded. If the CLC is valid, let's switch. Oops. Which means right. So Kelvin, you explained here correct also, but it's if error. If there's no error, then also explain what happened.
Oh, okay.
Okay. Cut through switching, forward the frame. After determining. Yeah, correct. Forget. Okay, yeah. Married to benefit issues, to miracles, yes. Yeah. Okay. What is the duplex setting of switches whereby a function is limited? Oh, okay. Full duplex, correct. It's on the same condition by. Yes, correct. Consequence connecting many switch together. If one host will every end was connected, we also receive the broadcast. Here you can say that the size the broadcast domain is increased because the broadcast is propagated from switch to switch. And in okay. Number 13. This Kelvin, are you looking at 13? Let me just share my screen so you can see.
Oh yeah, I saw I saw it too late, the collision.
Yeah, this is hub, right?
Yeah, the blue one's supposed to be the broadcast, and then the red one's supposed to be collision.
Yes. So you know what's wrong here? The hub here.
I think something's the hub one got one extra collision there. Yeah.
Yeah. You should. The whole thing is here. This part. There should not be a separation lah. Huh?
Yeah.
Yeah. Just correct that. It's okay. Okay, so that's 13 and Farah, and then 14 is Kelvin also. Kelvin 14 is 9, that's correct. Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's correct. All right, so when you draw, just to let you guys know, Kelvin and Noel, don't overlap the broadcast domain. And don't overlap the collision domain as well. Okay, you can see here is
sometimes quite hard.
yeah, no. but try not to lah, because overlapping simply means it means something different already.
Oh, a
Yeah.
different meaning. Oh,
Yeah, because like a Venn diagram can overlap means here is combined, something like that.
oh.
Yeah, try not to and
Okay.
try to end the edge of the ellipse at the
Only at the line. Only
at
the
at
line.
the end
Okay.
of the line. Yeah,
Oh, okay.
I know it's a bit hassle, but you have to be precise lah.
Okay.
Yeah, I remember main campus there. They want it to be very precise. So the marking, they want it very precise. Even though understood, I can see the meaning, but they want it really like that, really accurate. So yeah, just amend that to improve on it. So okay, so last one is Noel. Noel, okay. All right, so okay, so correct also our broadcast domain. All right, so Noel, you can also improve this. You know the two large ones, the two small ones. Okay, already. It should be like that. But the two, okay.
Oh, is it too big?
Yeah, it's slightly out of the the num towards the router edge
Oh,
there.
I see that. Yeah.
Mm.
Okay.
But your answer is correct lah. It's 4. Okay, so I think all okay. Now just Farah's portion lah. Later I'll message Farah to complete it after viewing our whatnot. Okay, so it's 4:36 already. Any questions before we end our session this afternoon?
So far, no.
No, okay, all right. Both okay, Noel and
Oh
Kelvin?
yeah, the
Yes.
the project meeting when? What time?
Yeah, I'm actually trying to contact this the person in charge in
Oh,
KL. Yeah,
okay.
yeah. As soon as I got some uh, reply from him, I will do it lah. I just saw the KL meeting is on the 8th. The briefing is on the 8th. So, but I'll try to this week lah. Okay. But
Okay.
if the person is busy, they may slight delay, but not longer than 8 lah, because I saw they also have the FYP briefing proposal briefing on the 8th, which is next week actually. I understand lah, because there's one day our classes not affected by the Deepavali, but I think some of the lecturers affected lah. Are you affected? Any of your classes affected by Deepavali?
Yeah. But
Yeah.
the one of them we still continue to have class that day lah.
Oh, right, really?
He said he asked us for permission first. We said okay, and then he said okay also.
Oh, okay lah. But the thing I just let you know, the FOCS, is it our faculty or different faculty?
I forgot.
It's accounting.
Oh, different faculty. No wonder.
Yeah.
Maybe different faculty got different rules, but FOCS, especially informers last time meeting lah, they say don't ask a student on public holiday to do classes lah. Okay, so I'm not sure. I don't know about other faculty, but FOCS, our faculty have strict instruction lah. If you notice that our DCIT, there's no lecturer from DCIT will ask you to continue then.
Yeah.
Yeah, probably because their faculty got different rules. I'm not sure. I don't know. And in any case, ours are not affected. But yeah, I'll try to organize something for the FYP this week. If not, latest by Monday lah, because they also have on Monday. Okay.
Okay.
All right. So I'll see you guys tomorrow for second
Okay.
class, second lecture, and tutorial.
Okay.
Same time tomorrow. Okay.
Okay.
All right.
Thank you so much.
Right. Thank you, Noel and Kelvin. See you guys
you.
tomorrow.